Because it is quiz time, I want you guys to write your answer, the letters down in the comment box, okay? So as you look at the questions, you'll notice that the way the question is being asked on the first side versus how it's going to ask you on the second side, one may appear longer than the other, but that's because of the way the question is written, okay? So right here, we're going to start right there. So I'm zooming in so that you all can focus on one question at a time. All right, so I'm going to give you 10 seconds to answer the questions, and then we'll check ourselves, all right? So here's question number 1. Matter of fact, I want you to do number 1 and number 2. All right, question number 1 and number 2. We're only going to start on the left side for right now. Question number 1. Which gas law states that pressure and volume are inversely related at constant temperature? So if you said Boyle's law for number 1, you are correct. And here's why you are correct. Remember, pressure and volume are Boyle's law, and the curve the graph that's associated with that is like a little curve. Also, when you look at the buzzword here, inversely, that word means that if the pressure goes up, the volume will go down. So they are opposites of each other. All right, number 2. Which gas law describes the relationship between volume and temperature? Which gas law describes the relationship between volume and temperature? So we talked about this yesterday also, and I see several answers in the comment box. If you said Charles' law, you are correct. And we're not talking about Charles from BMF, okay? We're talking about Charles' law from these gas laws. Okay, y'all know I gotta be silly, right? Just to make sure y'all get this. So Charles' law has a straight line, all right? There's a straight line, and because we said there's a direct relationship, that means that if the volume goes up, the temperature will do the same thing. It'll go up as well. Charles. Charles' law. So that is your answer for number 2. So letter B. And the first one was Boyle's. And by the way, a good movie to watch would be Men of Honor with Cuba Gooding Jr. and Robert De Niro, because they actually talked about the gas laws, Boyle's law specifically. I remember when Cuba Gooding had to recite the formula because he was going into the Navy. And that was a movie based on, all the things that happened during, the soldiers the men and women trying to get into the military based on race. Okay. But Cuba Gooding had to memorize this. And if you talk about Boyle's law, you also will see this in the medical field dealing with your lungs. All right. Dealing with your lung pressure. All right. Let's look at the next one. Number 3. If the volume of a gas decreases, what happens to pressure according to Boyle's law? We just talked about it. So again, if the volume decreases, what is the pressure going to do? It's going to increase. So for number 3, if you all put B, you are correct. That's right, Donnie or Danny. Yep. If one goes up, the other one has to go down. Speaking of which gas law explains why a balloon shrinks in cold temperatures? All right. So look, if you're talking about pressure, okay, and volume, you know that is Boyle's law. But now look at this one. They're talking about temperature and volume. The volume inside the balloon shrinks. The temperature is going to also shrink. So therefore, deals with whose law? For number 4, Charles' law. All right. Good job, guys. Good job. Okay. Number 5. Well, number 5 on this side. A nurse compresses an oxygen bag, decreasing the volume, excuse me, while temperature stays constant. What will happen to the pressure of the gas? I put A, let's see if you're correct. Decreasing the volume while the pressure increases. A is correct. Okay, next question. A hot air balloon rises because the heated air inside expands. Which gas law explains this relationship? Yep, B, Charles' law. Okay, now I'm going to give you a math-based problem right here. And I'm going to give you about 5 seconds to figure out the answer. Listen, you don't have to set this up. You can look at the numbers and tell. A gas has a pressure of 2 atms and a volume of 4 liters. If the pressure increases to 4 atms, what will the new volume be, assuming temperature is constant? Now remember, what law is this? If you know that law, then this is going to help you on this problem. Notice that your pressure doubled. If your pressure doubled, what's going to happen to your volume? Yep, period. That's right. It's Boyle's law. So you guys got to remember that if your pressure doubled, your volume is going to be reduced by a half. So your volume that was 4 liters above, cut by a half, is equal to 2 liters. So letter A is the correct answer. That's right, Donnie. That's right, Danny or Donnie. That's right. One goes up, the other one goes down. We're going to do these two, okay? This is number 8. A sealed oxygen tank is heated accidentally. The temperature of the gas increases while volume remains constant. What happens to pressure? Now, I know y'all are probably saying, wait a minute, I don't remember this one. So we're talking about, even though this is this is Gay-Lussac's law, but with Gay-Lussac's law, in case some of you are like, wait a minute, I don't remember this, I'm going to explain it, okay? So with Gay-Lussac's law, matter of fact, let me just write it up here so y'all can see it, okay? Because I know a lot of students, like some of y'all said, oh, I always forget which law to use. I always forget which one I have to use for this one. Well, y'all, Gay-Lussac's law deals with pressure and temperature, okay? Gay-Lussac's law deals with pressure and temperature. Now, with pressure and temperature, this just simply means that if one goes up, guess what's going to happen to the other one? They're going to do the same thing, okay? If the pressure goes up, the temperature goes up. If the pressure goes down, the temperature goes down. So therefore, when you talk about Gay-Lussac's law, it says that the temperature of the gas increased, the pressure will also increase. So letter B. This problem. A balloon has a volume of 2 liters. At 300 Kelvin, if the temperature increases to 600 Kelvin and the pressure remains constant, what is the new volume? Now, again, your test will look something like this, y'all, where they're going to give you numbers that you don't have to use your calculator for, okay? If you think about it, you didn't really have to plug anything in as long as you know the rule. So if your temperature increased, so basically the temperature doubled, the volume is going to also double. So the answer is C. Yes, the answer is C. Okay. And let's look at, this is the last one in this category. Okay, number 10. A respiratory therapist warms inhaled air before delivering it to a patient. As temperature increases, what happens to the gas volume according to Charles' law? Y'all should already know this one. We just did it. Yep. Increase, you are correct. Yo, Pierre, yep, you are correct. Now, let's move over here to the ideal gas law. Let's see. Let's start you off easy. Which equation represents the ideal gas law? Since a lot of you all were talking about the gas laws and saying how you get confused with them, you should know this one, okay? You should know this one. Yep, C. Okay, let's talk about what the other ones are, okay? Whoops. Let's talk about what the other ones are. Because we know that the answer is C for this one, what is the first law? What's the first law up here? What's letter A? Yep, yeah, the first one is Boyle's law. The second one is Charles' law. And yes, the third one was the ideal gas law. Speaking of which, let's take a look at this one over here now. Okay. A container holds a gas at constant temperature. If the number of moles increases while volume remains constant, what happens to the pressure according to the gas law? All right, so again, you all know it's PV equals nRT, right? So according to just working with just what you got right here, a container holds a gas at constant temperature. The volume increases. What's happening to the pressure? What happens to the pressure? So for this one, guys, the answer is A. The pressure increases. Okay, the pressure increases. So this one right here, you're going to have to go and dig into your notes so that you all can understand the process with this particular gas law, okay, with the ideal gas law. All right. A nurse warms oxygen in a respiratory system while volume stays constant. According to the ideal gas law, what will happen to the pressure? Yep, for those of y'all that said A, you are correct. You are correct. Okay, next question right here. A gas sample has a temperature of 300 Kelvin and pressure of 1 atm. If the temperature increases to 600 Kelvin and volume stays consistent, what happens to the pressure? What happens to the pressure? Yes, if you said doubles, that is correct. That is correct. Now, I'm going to switch you guys back over here on this side. And these, you should be able to go through these really quickly, all right? So right here for number 5, This is just seeing if you all know what the variables represent, because a lot of students, for some reason, ask me, well, what's the P for? What's the V for? What's the N for? Y'all, if you don't know these variables, you're going to be in trouble, okay? That's how you solve the problem. So for number 5, what's the common unit used for temperature? If you said Kelvin, you are correct. Kelvin is correct. Number 6, which variable represents the pressure in the ideal gas law? Which one of these? For number 6. P, that is correct. P is correct for pressure. I don't know why this thing keeps moving, but yes, P is correct. Okay, last question right here. Last question right here. An oxygen tank in a hospital is accidentally heated. The temperature rises while volume stays constant. What happens to pressure according to the ideal gas law? Joy, you got it correct. A, pressure increases.